So this time, let us try to use the statistical test for the difference between two means, which is the t-test, in which there are two independent formulas for t-test. One is for equal variance and the other is unequal variance. Let us assume examples here from the data bank. Example, we have the respondents, and then there are actually 20. Okay, so the respondents are grouped, no? So as I look at it, I group already the respondents according to Filipino groups, no, under analysis, in which in the groups we have to consider the height of the Filipino students, for example. So as you notice, the respondents number are not arranged because we are grouping already the respondents according to the group they belong. However, you can also rearrange that by having the sort command. Na you click column A instead of column B, and then if you click OK, then that means it's already arranged by numbers, so 1 2 3 4 5 until 28. And this is important also for you to track the data of per student under analysis, the height of the student under analysis. But however, to facilitate easy and fast computation, we have to group them according to the group they belong. So that's why we have to group them to Filipino group. So we have to highlight all, including the respondents number, and go to custom sort, and we choose B, that means the Filipino group, and then OK. So if you look at now, all group A are together group, then group B also in the second group, and all the heights for the different students are also aligned. So we have to highlight all, as you see a while ago, because that means if you group them, you have to avoid the disarrangement or the mismatching of the data. Okay. Now, again, we are going to analyze whether the height of group A is significantly bigger or different from the height of group B. So since we are talking about the height, is it that group A is taller than group B? So are the height significantly different from each other? So that's why we have to test it using statistics. Now, let us understand first that t-test can be used for uh, analyzing between two groups, and that two group belong the data from that two groups belong to one variable, which is the height in our example. Can be using means because we can compute the mean of the height, and the height can be classified as ratio because they can be ranked, the numbers are can be computed accordingly, and we can also consider zero as significant, meaningful to the value. So that's the reason why we can use the t-test for using means. And remember that t-test, there are two independent samples. One is for equal variance and the other is unequal variance. And in our example, let us see which variances this example belongs, and we can also use which t-test after in the analysis of the data. But before that, let us consider the assumptions in the use of t-test. And the assumption should be, the basic assumption is that you can use the data is normally distributed or the number of data is less than 30. In our example, we have 28, so it belongs here. However, there are also many researchers who still use t-test despite the number of data is more than 30, considering that they assume it's still a sample and the population is too large, so that's why they opted to use t-test. And there are also another statistical test if you can use more than 30. And another assumption must be the variance is known. If we cannot find the variance in the group, so therefore it's difficult for us to use the t-test. As we have an example here, this is usual statistical problem in the research. No, if you remember, if you construct a research problem, the first problem is what is the height of the Filipino. So that's why if you look at the data, this is the data, this is the height of the Filipino students example. But for analysis whether the height of Filipino A and B are significantly different, we have to ask that in the statistical problem whether is there significant difference in the height of the Filipino A and B, between A and B. Okay. So meaning we have to consider whether the height of Filipinos belong to group A are significantly different from the height to Filipinos belong to group B. And we can use alpha level 0.05. Later, you will understand the importance of that alpha level in the analysis. What do we expect after analysis? We have to come up with what are the variables under study, what are the means of this group, the variances of this group, and the sample sizes, and then what t-test result, and what is the critical value. The critical value is important, which is a reference whether the t-test is going beyond or below or does not go beyond the critical value, because we have to decide whether there is significant difference. And if there is significant difference, then the null will be rejected, or if no difference, the null will be accepted. And so what does it mean if the null is accepted or rejected? We have to put an interpretation. That is the summary table, which is important to be reflected if you put this in the data analysis part or in the uh, interpretation of data part in the research manuscript. Now, we have to consider first that before simply using the t-test, we have to check the test of normality. The test of normality is important to check if the data is normally distributed or not. We don't have a question about whether the data is less than 30 because our example is 28, which is definitely less than 30. Now, we can use the formula as reflected in the book of Bluman, 2012, Elementary Statistics. This is the 8th edition. So there are books available by Bluman in which you can find there in that page how to determine the test of normality. And we have the PI, the Pearson Index, as the formula useful in finding the test of normality. By formula, we have to get 3 times mean minus the median over the standard deviation. The mean here refers to the mean of all the students under study, regardless of what group they belong. So, meaning, in our example, we have 28 students. So, therefore, the mean should be the mean of the 28 students, not of group A and group B. So, we have to analyze in the test of normality together as one data. Also, the median of the group, the two groups, so the median. And we also have to get the standard deviation. And then, in this case, we have to consider also, so I have here the values, but we will change that. We will try to look at what are the values in the given data. And then, so in that case, first, we have to get the mean of the group and the median and the standard deviation. So we'll go back to the data set. These are actually the height of the students and or the pupils. Then we have here group A and group B as our identity that that student belongs to group A or B. So what do we have is what is the mean of group A and what is the mean of group B. So the first thing that we do is we have to get the mean of all the groups. So you have equals average. You just use the Excel command so you can get directly the answer. Equals mean is equivalent to average. So equals average, highlight all the data, enter. So that's the mean of all groups. For median equals median, then highlight also all the data, and that's the median of the group. And then we get the standard deviation. So you have equals ST, then dev. Look at ST dev, that S because it's sample, that P if it's population. So double click that, then you have the option now to highlight the data set under analysis and then enter. So these are now important in determining our Pearson index for test of normality. So let us round off this, or we will not round off, but for those who are using calculator, they will round off to 2 decimal places. But in this case, we will not round off, so let us copy this. That is the mean of all the group, and we will put it here. Okay, so that is the mean. Okay, so I will paste it here. Okay, so we'll just go back. So what is important is we have to determine the Pearson index. Okay, so before we compute, let us try to analyze that. We have to determine the Pearson index by subtracting mean by the median, and then multiply the result by 3, and then divide it by the standard deviation. And if the data is within the range of -1 to +1, so according to the Book of Bluman, it's normally distributed. But you can also use the other test of normality as we have in the other video using the skewness. So you can use also that for test of normality. But in my example, I can use the simplest one, which is test of normality using Pearson index. So let us copy that here, and then let us analyze what is the PI. So our PI now is equal to, so as you notice, there must be parentheses. It's a bracket, and then the parenthesis here. So it has to be 3. Then times, we use the asterisk, and then parenthesis again, the mean, which is here, minus the median, which is here. Close that, and then you put another parenthesis since we cannot use the bracket in the Excel command. Over, no, you have that symbol. Then again, you have to highlight the standard deviation, then close. There, our PI is 0.45. So as being mentioned, we can say that it's normally distributed when the value is within the range of -1 to +1. So in this case, we can assume that it's normally distributed. So therefore, we are now free to use the t-test. If the data is not normally distributed, we will use another test of analysis, no? Maybe the non-parametric test. So we can say it's normally distributed. Okay, so our assumptions now are met. So let us try to analyze. The data now is normally distributed, or the number of data is less than 30, and the variance is known. So we can also get the variance. Now let us try to solve now whether our t-test to be used is the t-test for an equal variance or equal variance. And how do we know? We have to use another test, which is the test you can study, or you can research also from Decor and Cochran 1983 from their book. No, so you can find this in their book. The test of equality of variance, we call that F test. So how do we compute the F test? If that larger variance is divided by the smaller variance. Okay, so what will happen? Okay, so in this case, you have to divide first the larger variance by the smaller variance. And then you have here the CV. When we say CV, it's the critical value, in which we have to consider the DF, the n minus 1 of the DF. We have to consider n minus 1 of the DF numerator, and n minus 1 also of the DF denominator. So I will just write n, meaning n numerator, and then n2, I will just write n denominator minus 1. And then we have to find that in the table, which we are going to search later. Now, you have to decide later, and we have to note that we can only say that the variances are equal if it's insignificant. Equal variance if insignificant, but if the variances are equal, then it's significant. So you will understand later how do we do that. Okay, so we are going to solve now the F value as mentioned in the book of Cochran and Snedecor 1983 as our reference. So in other words, we have to get the variances of the group. No, so we have to get the variance of the group. This is group A and this is group B. So first you have to get the variance, so equals var dot s, because it's sample. So you highlight the variance for group A. So you go to the data, group A. Okay, there. Enter. And then you have equals variance var dot, okay, S for group B. So you highlight group B. There. Enter. So in this case, we have already variance for group A and variance for group B. Now, later you will need the mean in using the formula, but we are still whether the data is the variances are equal or unequal. So we can choose whether we choose the first formula or second formula. So in this case, we can say that B is bigger than A in terms of variances. So how do we get the F test? According to the formula, F is equal to the quotient of the bigger, so the bigger variance, which is the bigger variance B, divided by the smaller variance, which is A. Okay, so the answer is 1.52. So the bigger variance, which is B, divided by the smaller variance, which is, okay, A. So F now is 1.5294. Is F significant? How do we know? We have to find the critical value. Okay, so we have to get the critical value, and in finding the critical value, we have to determine what is the degrees of freedom for numerator and what is the degrees of freedom for denominator. Okay, so how do we find that? We have to search that in the table. We will search that what is available in the internet. Okay, and let us remember how many students belong to group A. So let us count first. How do we know how many students belong to group A? That is N. So in this case, there are, you look at below here, 18. So you can put NA is 18. So since it's 28, so automatically NB is 10. Okay. So that's the N. NA O and NB. Okay. Okay, that's it. So in this case, in order for us to avoid the error, so you can put here N, example N, and then you will just put that here, transfer 10 here. So meaning N of A, look at here the intersection, then N of B, and then we will delete this part to avoid confusion. Okay. So what else do we need to compute? Again, we have to get now the critical value in order for us to decide whether the variances are equal or not equal. How do we do that? We go to the internet and we look for, we search in Google, example. So we can also use another platform. And then you are going to look for this F distribution table. Okay, and then let us decide which table we are going to use. So how do you know that you are looking at the correct table, or you will be using the correct table? Okay, you just look at the degrees of freedom numerator and degrees of freedom denominator. Example, we will use the F distribution table z-score now from the internet. I hope you can see it here. Okay, if we will visit the website of this one. Okay. So, as you notice here, there are numbers, degrees of freedom in the numerator, numbers 1 to 9. And then, there are also numbers below, that is degrees of freedom denominator. Or we can look for the other simpler table. Okay, for as long as you can see the numerator and denominator. The numerator is going horizontal and the denominator is going, okay, vertical. So let us try to visit this one. Okay. So how do we know our degrees of freedom numerator? The numerator, if you remember in our formula, in the one that we are solving, our numerator refers to the variance of the bigger variance, the group of the bigger variance, and our denominator refers to the uh, group of the smaller variance. So again, look at our bigger variance is B, and our number of students there is 10. So our n for numerator is 10 and our n for denominator is 18. However, for the degrees of freedom, that should be n minus 1 and for both numerator and denominator. So our numerator is 10, then minus 1, so our degrees of freedom is 9. Then how about for the degrees of freedom denominator? For the degrees of freedom denominator, we can use the n, no? If you remember the n, in which the n of the variance, smaller variance. So in that case, the smaller variance is a. So our n is 18. So that is 18 minus 1. It is 17. So we look at the intersection, no, in the table, in which we have to find the value, the intersection of 9 in the numerator and 17 in the denominator. So we'll go back now to our table, reference table. Okay, so we can look at here. I don't know if you can clearly see. Okay, so just check it with you. So try to look at our n. We have n minus 1. 8 minus 1 is 7. So we go to 7. Okay, however, you should be careful as to which table you're going to use using alpha. Because if you are using the two-tailed, for f distribution, we have to divide it first by 2. No? So because we need to divide it by 2. So in our example, if you go back to our example here, what alpha that we are going to use in this? Okay, so to determine the variance, in this case example is we are using alpha 0.05. So what we will do is we divide 0.05 into 2. So the result now is 0.025. So we look at table with 0.025. So in this case, that is 0.10. Okay, that is 0.05. And then here, 0.025. This is half of the alpha that we set, which is 0.05. So therefore, we will use this one because it's two-tailed. Now, it's 7. You go down to, what's it? 18 minus 1, 17. So 17 is here. 7 is there. So that is 3.1556. No, so never mind if you cannot find it. You just try it in your own computer. So it's 3.1556. Thank you for this website. No, so for the table as our guide. So 3.1556. Okay, so we'll go here. Our tabular value now is 3.1556. 3.1556. Okay. So let's review again. That's 3.1556. That is already our critical value. So therefore, we compare the F value 1.5294 and the critical value is 3.556. So if you look at the F computed does not go beyond the critical, the boundary. So that means no significant difference in the variance. So they are not varied. So our decision here is that it is insignificant. And if you analyze, usually our null hypothesis is that there is significant difference. But in this case, it's insignificant. So our null is no difference, no difference. But then it's accepted because as a result, it's insignificant. So therefore, our null is accepted. Okay, so we are now accepting the null hypothesis again because our null hypothesis says that there is no significant difference. And it so happened that there is no significant difference because our F does not go beyond the critical value as we referred it to the table. So what does it mean now? So our interpretation here is that Okay, our interpretation is that they are equal. Equal variances. Okay, again, remember we are still in the analysis whether the variances are equal or not. Now, finally, we can say the variances are equal. Why? Because there is no significant difference, no insignificant. The null is accepted. The null says there is no difference and it's accepted, so therefore equal. Okay, so that's the meaning of the null hypothesis. And the result here is equal variances because the null means none or are no difference. Okay, so in this case, we are now free to use the equal variance. So where is the equal variance? This is the equal variance formula. So we will use this t-test equal variance, and then we have to continue now, no, as expected solution in order for us to analyze whether the height of the students are significantly different from the other. Okay, so as we have here, again, we can use now the t-test of independent samples with equal variance. So as being reflected in the table, we have to know first the variables, the mean, the variance, and we can put it here. Number one is the height of Filipino A and B. The second is Filipino A. We are talking about the mean. Okay, so we have to get the mean of Filipino A and the mean of Filipino B. So what is the mean of Filipino A? We have to first to get the average. Okay, average of all the data that belongs to group A. Okay, here. Equals average. And then again, equals average. Open parentheses, highlight all the data that belongs to B. Belong to B. There. So the mean is 1.2617 for A and for B is 1.34. Again, so that's the mean, 1.2617. So you can put it here now. Okay. The mean for A, it's 1.2617. 1.2617. And the mean for B is, okay, so let us try to check. The mean for B is 1.34. Okay. Okay, so let us try to look at now. The mean for B is, okay, 1.34. Now, number 3 in the table is we have to get the variance, but we computed already the variance here. So, for A and for B. So, the variance for A, okay, so we can copy that. Okay, I can put it here with this value, so I can copy paste. Okay, let us assume that that is the value for the variance of A. So, number 3, the variance for A, and then, okay, example that's the variance for B. What is good in using the Excel in computation is we do not think of rounding off. We use all the values. But if you use calculator, you have to round off because you cannot put all the digits together. So what is the fourth place? So the fourth is the sample size. So let's try to recall. For A, there are 18 and for B, there are 10. So our A is 18 and for a B is 10. Now, the fifth one here says we have to get the t-test result. This is the formula. N minus N1 minus 1 times the variance squared or the variance plus N minus 1 of the second N, then times the variance of that over N1 plus N2 minus 2 times square root of 1 over N1 plus 1 over N2. That is the, you get the square root of all, then that is the divisor of mean 1 minus mean 2. So, in the formula, we have first to get mean 1 minus mean 2. So, let us try to solve here. Okay. So, we have mean 1 minus mean 2. Okay. So, how to solve the mean 1 and mean 2? Equals, okay, A minus B. Okay, that's the value. Another is, okay. Okay, next is, based on the formula for equal variance, you still have to get first n1 minus 1 times the variance, then plus n2 minus 1 times the second variance, then divide it by n1 plus n2 minus 2. So we will get first ibabaw n1 minus 1 times the variance squared plus n2 minus 1 squared n. Okay, so we will first get n1 minus 1 times, say, variance of group 1 or group A. Okay, so that is equal to, so the n of the first group, so the n1 refers to the n of n1 refers to the n of A, the first group. So there are, in the first group there are 18, so 18 minus 1 is 17, so equals 17 times the variance of group A, which is this, enter. Another is, we still have nb minus 1 times, again, variance B. Okay, so that is equal to, our n for B is 10, so that should be minus 1, 9, times the variance of B is 0.9156. Okay, enter. So that's it. So we are done with this already in the numerator. You still have to add that, no, add the first and the second, and then divide it by n1 plus n2 minus 2. Okay, so add, let us assume, this is the first, this is the second, and this is the third. Okay, so this is the first process, and then this is the second process. So what happened for the second process? Supposedly this is n b minus 1 times variance of B. Okay, so we'll now go to the fourth process. And the fourth process is simply to add that. If you look at the formula, you need to add the two products. So you add that, so meaning 2 plus, 3 plus 4. Yes, 2 plus 3. So what happened in 2 plus 3? So that is, you add, no, the first result plus the second result. Now after that, we added it already. We need to divide it by the sum of n1 and 2 minus 2. So meaning, we get first the sum. The fifth step is sum, or you will get here na plus nb minus 2. So let us try to remember what is na. So 18 plus 10, then minus 2 equals, okay, the result is 26. Then you divide what happened in number 4 after you add by the result in number 5. So for the number 6 step is, you have to divide 4, divide it by 5. So meaning, you divide the result in 4 divided by the result in 5. There. Okay. You will have to divide 4, okay, divided by 5. Okay. 4 divide 5. That's the sixth process or step. Then after that, if you look at it, look at the formula, we are done adding this and we divide it by this one. What is next is we get the square root first. Okay, we get the square root. So meaning we get the square root. That's the seventh step. So that is square root of 6, of step 6. So how do we get that? Equals square equals sqrt open parenthesis, click the result in 6, enter. We are done with this first square root and we will now proceed to the next one. So that is 1 divided by n1 plus 1 over n2. You add that first, then you get the square root. So I think we can summarize that, number 8. So first, square root, square root of sum of 1 over NA and 1 over NB. Okay, so how do we reflect that here? Okay, equals SQRT open parenthesis, and then you have to open parenthesis again 1 divided by NA is 18, so 18 close, then plus open parenthesis 1 over NB is 10. Okay, 1 over 10 close, close. Okay, that is the square root. Okay, so let us clarify. So again, you get the square root, then open parenthesis, open again, 1 over 18 because 18 is n1, which is A, and 1 over 10 because it's n of B, and you put plus, and then you have to put parenthesis last in order to enclose that before the square root. Okay, that should be done here. After that, the two square roots shall be multiplied. That's the operation for mathematics, considering that. So we are now in the number, okay, we are now in the number 9. Okay, so we have to multiply which one, if you remembered, the square root of this by the square root of this. So the square root of 6 and the square root of, the 7, multiply 7 by 8, both the square roots. So equals, multiply, asterisk, this one. Okay, that is already the value. Okay, so that is still the denominator, but if you look at the formula, that is still the denominator after the product of the two square roots. You still have to use that as divisor of the difference. So where is the difference? If you go back, mean 1 minus mean 2 is the difference, or mean A and mean 2. So that's the number 10 step. So you have to divide what happened in step 1 by step 9. Okay, so you divide now, equals, okay, step 1 divided by step 9. Okay, again the result is, okay, step 1 divided by step 9. Okay, so the answer is negative 0.746. Okay, so the next question is, how do we know that it's significant? No, we are analyzing this time whether the height of the Filipino in Group A is significantly bigger than the height of the Filipino in Group B. Okay, so after finding, so we can have already the t-test. The t-test value is equal to negative 0.7463, round off. So we can put it here. Okay, so we can put here the mean. If you look at the mean of A, okay, so it's 1.2617. For B is 1.34. For the variance of A is 0.05986, and then 0.09155. The sample size of A is 18 and for B is 10. And the t-test result as computed a while ago is is negative 0.7463. It's negative 0.7463. What is now the critical value? And what is our decision? So our critical value shall be referred to the table also in t distribution table. So the critical value, you should know that the degrees of freedom is equal to n1 plus n2 minus 2 for equal variance. Okay, so there is another DF computation for an equal variance. Okay. Okay, so meaning we have to find the degrees of freedom, which is n1 plus n2 minus 2. So again, our n1 plus n2, 18 plus 10 is 28, minus 2 is 26. We are using this formula for equal variance, different formula for an equal variance. So we will go now to the internet and decide to search now, this time T distribution table, not F distribution. Okay, so let us visit now what are table available in the internet. So this time we don't need to divide the alpha we set by 2, unlike in the F distribution we divide it by 2. But this time we will just, okay, so too small. Okay, let's try to visit other table which is bigger. So that means we have to look at the degrees of freedom 26 at alpha level 0.05. Okay, so we are now in two-tailed. Our intention is to know if there is significant difference. But if your intention is to know if group A is larger or taller than group B, so that's different. We used one tail because of the word larger or taller. But because we are using the two tail, the problem that we have in our example here is there significant difference only? So therefore it's two tailed. If we change the word difference to taller, then we will use one tail. But this time, we will use the two-tailed. We look at 0.05 as we set. And we look at DF until 26. Okay, 26. So it's 2.056 under 0.05 two-tailed. Again, it's 2.056. So in here, we are going to go back now to, okay, this is 2.056. Okay. So that's 2.056. So compare now. So this is two-tailed, so it's either positive or negative. So the result is either positive or negative. And if you look at, okay. Okay, so if you look at, it's negative and it's negative. So if you look at to the left, no, the line, number line going to the left from 0. Okay, so let us assume. Okay, so it's positive or negative. So it's plus or minus because it's two-tailed. So if you look at the number line, example 0 going to the left is negative 1. To the left is negative 2. Then to the right of 0 is positive 1. Then to the right of 0 is positive 2. So as you notice, negative 7 is somewhere here. And negative if it's negative, we will use also the negative here. If it's positive here, we'll use the positive. So 2.056 is somewhere here. And the value is just here. So how do we know that there is significant? If the value is beyond the critical, so it's somewhere here. If the value is somewhere here, but what happened, the value is not beyond the critical, so our decision here is insignificant. And what will happen to the null? Our null is there is no difference, so therefore our null will be h0 will be accepted. So if the null is accepted, that means equal. So therefore, the height of Filipino in group A are equal to the height of Filipino in group B. So upon inspection, we notice that the group B is taller than group A, but that is not significant. According to statistics, they are equal. So meaning by chance, no, by chance, there are those heights different from the other group, but in general, they are the same. Not significant difference. So that's our target if you use the t-test. Okay, so this time again, we are using the t-test for equal variance and another video for the t-test of unequal variance. Thank you, everyone.